Okay, question 2. The discrete random variable x can only take the values 1, 2 and 3. For these values, the cumulative distribution function is defined by f of x equals x cubed plus k over 40 for values of x, 1, 2 and 3. Show that k equals 13. Okay, because it's cumulative, this big F, that means that f of 3 must equal 1. The final value that I put in must equal 1 because it's cumulative and the total probability must equal 1. So that implies that 3 cubed plus k over 40 must equal 1. Multiply both sides by 40. 3 cubed plus k must equal 40. 3 cubed is 27. I'm going to take 27 off both sides, so k must equal 40 take away 27, which is indeed 13. Next part, find the probability distribution of x. Well, the next thing I'm going to work out is actually f of 1. So let's work out the first value. So we're going to get 1 cubed plus k, well we know k is 13, over 40. Let me just change this symbol to an equals. So f of 1 is going to equal this. 1 cubed is 1. 1 plus 13 is 14. So we get 14 over 40, which is in fact 7 over 20. Okay, let's see if we can start to build a table. So here we have the particular values of x, and this is the probability that my random variable equals these particular values. So we had 1, 2 and 3. Now we know when f of 1 is 7 over 20. Let's see if we can work out f of 2 now. Is going to equal 2 cubed plus 13 over 40. 2 cubed is 8. 8 plus 13 is 21. So you get 21 over 40. And that's f of 2. But remember, f of 2 equals probability that x equals 1 plus the probability that x equals 2. Now we know the probability that x equals 1 is 7 over 20. So that's 7 over 20. Let's write it as 14. 14 over 40, which means that this value, x equals 2, must be 7 over 40. So I'm going to write this as 7 over 40. And then finally, to work out the last value, well, we know that all the probabilities have to add to 1. That's 7 over 40. That's 14 over 40, which is 21 over 40, which means this guy here must be 19 over 40. Hence our probability distribution is found. Next part, given that the variance of x equals 259 over 320, find the exact value of the variance of 4x minus 5. Okay, so let's just write that information down again. Var of x equals, well, we've got 259 over 320. We want to find var of 4x minus 5. Well, we have to know this rule that the variance of ax plus b, so if we apply a linear transform, to the variance, we get a squared times the variance of x. So, variance of 4x minus 5 is going to be 4 squared times all of this, 259 over 320. We're going to get the calculator to do this. So, take out the calculator. When it comes out, calculators give me a bit of bother. When you work this out, we're going to get 259 over 20.